Fellas, this is a review on Unit 1 of AP Physics C Mechanics, which is Kinematics. Uh, I will be posting such unit-wise reviews on my channel, so make sure you subscribe and hit the notification button. You can download this PDF from the link in the description, and if you need private tutoring, feel free to reach out. All right, first question, we are given a graph that shows velocity versus time for a puppy moving along a path. Um, According to the graph, when does the puppy change the direction, if ever? So what is the concept, guys? When does a particle changes direction? When velocity changes the sign. Um, Fortunately, this graph is a v versus t. So I can see that this is the point where the velocity is changing from positive. I can see that this area is positive, or this region is positive, to negative. And this looks like 7. So among these options, the option C, 7 seconds, makes the most sense. All right. Here we are given that Donald is standing near the ninth hole waiting for his friend Chris to return with the golf cart. Chris is in such a hurry to get to the next hole that he does not slow down as he passes Donald. Okay. The graph shows the velocity versus time for both Donald and Chris as Donald tries to catch up on the cart, to the cart. Chris passes Donald at t equal to 0. How many seconds pass between the time the golf cart initially passes Donald and the time that Donald reaches the cart again? So basically, this is how Donald is going. He's initially, and this is, by the way, velocity versus time. That's already given in the question. This is v versus t. This is velocity, this is time, this is how Donald is traveling, and this is how Chris is going just steadily, on the cart. So don't you think it makes sense that Donald will catch up with the Chris when the distance covered by the cart is same as the distance covered by the Donald? Obviously, velocity, time curve, area under the curve gives us displacement, but fortunately here there's no change in the direction, right? So can we agree that distance and displacement are same? So we can safely assume that the area is indeed giving us the displacement, which is same as distance. Now, one way is to approach by options and see which one is, at which point the area is adding up, or, something like that, or make a calculated guess. So let's say, for example, this is let's calculate till this point what is the area covered by both the parties, and this looks like 1.5 to me. So the area covered by the cart will be base times height, because this is a rectangle, so 2 times 1.5, which is just 3, right? So that's 3, and I think meters, or I don't really know what the unit is, but anyway, it doesn't really matter. For Donald, the area will be half times base, which is 1.5, times height, which is 3, and this is 2.25. So definitely not till this point. Now I need some more time for Donald to catch up with the Chris. So for the cart, let's say it happens at some time t that I do not know, right? Some time t over here. So can we agree that for that much more time after 1.5, the area of the cart will be height, which is 2, multiplied with whatever length we have over here, which is just t minus 1.5, right? T minus 1.5. And over here for Donald, after 1.5, the approach is pretty straightforward, because this also becomes a rectangle as area under the curve. So let's say for this t, and this is the height 3, so this will be the area for Donald, right? Which will be height as in 3 units multiplied by the time, which is t minus 1.5, right? And I want these two to be equal right now. So all I have to do is just simplify this a little bit. Let's open this up. So this will be 3 plus 2t minus 3. So actually this will just become 2t. And this will become 2.25 plus 3t minus 4.5, I believe. So this will be 3t minus 2.25, and I want these two to be equal, right? So I want 2t to be equal to 3t minus 2.25. Let's subtract 3t both the sides. So minus t is equal to minus 2.25, and clearly the total time is 2.25 over here. So 2.25 seconds is the time when Donald finally catches up with the cart. Right, I hope this makes sense. Cat is running with a constant acceleration. Initially at rest has a velocity of 1 meter per second. At 2 seconds later, at t equal to 4 seconds, how far away from the starting point will the cat be? Okay, looks pretty straightforward. There is an acceleration over here, and initially, and has a velocity 2 seconds later. So at this point, it starts from rest, by the way, and at this point it has a velocity of what, 1 meter per second, and this is 2 seconds. At t equal to 4, how far away from the starting point will the cat be? So they're asking it travels for 2 more seconds. So they need the entire distance traveled. Okay. I don't really know the acceleration, so I can use the first half to find the acceleration. I believe I can use V final is equal to V initial plus AT equation, because V final I know is 1. V initial is 0 because it starts from rest. Acceleration I do not know, and the time is up 2 seconds, that's given. So 1 is equal to 2A. Let's divide both sides by 2. So 1 over 2 is equal to A, or A is 0.5 meter per second square. And now I can just take this entire motion as a, entire segment as a single motion. And I believe I can use the second equation of motion, because that will give me S is equal to V initial times T plus half AT square. So S will be equal to V initial, fortunately is 0. Acceleration is constant, so if you want I can write 1/2 rather than 0.5. And time, be careful, it's the total time is 4. So it'll be 1 over 4 times 4 square 16. So the answer will be 4 meters over here. So it should be option D. Right? I hope this makes sense. Okay. A rocket is tossed vertically upward from a roof of a building where air resistance is negligible. Which of the following best describes the rock's velocity as a function of time? Velocity, be careful. So we have to take the direction into consideration, right? So they are saying that the top of a building, maybe somewhere over here, it is thrown upward like this. Um, okay, definitely not A. How can A be the answer? Because how will the scenario, how will the scenario be? I mean, it will go up, it will slow down, eventually it will come at rest, and then it will again come down, and after some time it will have the same magnitude but in the opposite direction, right? And then it will keep on increasing, in the velocity will keep increasing as it falls down the building as well. So obviously E is also not possible. Now, the question B is also not possible. Why? Because it is not getting 0 anywhere eventually after some time, right? These two make sense because they are eventually getting 0 somewhere, and eventually they are also getting negative. But remember that this is a free fall, right? This is in the air, and in the air the acceleration is always negative g, or g downwards. And what is the acceleration? Isn't that the slope of the velocity time curve, or dv over dt, right? And if dv over dt is a, and a is constant, so obviously I'm looking for a curve where the slope is always constant. Now c doesn't make sense because the slope is changing at every point, which means that the acceleration is changing at any point, which is not correct because the air resistance is negligible. Had there was air resistance, then it's likely that, okay, because of air resistance, the acceleration is changing, but it is negligible. So it should be a constant slope, a negative slope, which happens only in option D. So I will mark D as my correct choice. Okay. A frog that jumps upwards from the ground is under the influence of of gravity. If it has an initial upward velocity of 5 meter per second, approximately how far above the ground will it be when it has a velocity of negative 2.5? So it jumps with 5 meter per second. It goes to some point. Obviously, it will come at rest at the topmost point. And when it comes down, it will have a negative velocity. And somewhere over here, it has 2.5 meter per second in the downward direction. They're asking what is the displacement, because how far above the ground will just be the displacement. I think I can use the third equation of motion, which is v final square equal to v initial square plus 2as, because v final is minus 2.5, v initial is 5, acceleration is acceleration is negative g, because I'm taking downward direction as a negative one. So g is, I don't know, maybe take negative 9.8 or 10. Let's take negative 9.8 and see how the options look like. As so, let's solve this up. This is 6.25. This is 25. This is 19.6, I believe. As 6.25 minus 25 is negative 18.75. Sorry, 18.75. Negative 18.75 is equal to negative 19.6. S divided by negative 19.6 will give me the answer as 0.96 meters. And yes, fortunately, this is in the option, so I'm going to mark option B, right? Hope this makes sense. Okay. The position of a particle when the time varies is governed by this equation. So what is the acceleration? That's pretty straightforward, right? What is the acceleration when it changes the direction? I'm sorry. So still, first we need to find the expression for the acceleration. For acceleration, first we need the velocity from the position time curve. Velocity is given by dx over dt. Recalling our math skills, guys, power rule. So this will be 3t square minus 12. And acceleration, guys, is dv over dt, right? Take another derivative of this guy. So it will be 6t. But they need the acceleration at the time when it changes the direction. And when does the velocity changes direction? When obviously it changes its sign, right? So this is the velocity. I'm going to factor this vector the 3 out. So it will be t square minus 4. And t square minus 4 can be written as t minus 2t plus 2. So again, I'm going to make a number line over here. This will be negative 2. This will be 2. This is just calculus, guys. I hope you understand what I'm doing here. I'm just making a number line, plotting the roots. Take, honestly, negative 2 should be ignored because this is a negative time, but it's okay. Any number greater than 2 that you like, maybe 100. And if I put 100 over here, this will come out to be positive. Likewise, any number between negative 2 and 2, let's say 0, this will come out to be negative, and this will be positive. So the points where the velocity is changing the sign is negative 2 and 2. Obviously, negative 2 should be ignored because that's a negative time. So I'm just going to take positive 2. So the acceleration is 6 times at 2 seconds. It will be 6 times 2, which is 12 meter per second square. So that should be our answer, which is option E. I hope you are finding these solutions helpful so far. If you are, then please, like and subscribe, share this video so that can help other students as well. It will also help my channel, and if you need private tutoring, feel free to reach out. Okay, let's try the next one. Uh, Aaron was biking due east but had to stop for a traffic light. Just as the light turned green and Aaron began to accelerate at a constant rate, his friend Betty sped by on her bike traveling in the same direction with constant velocity v. If it took Aaron time t to accelerate to Betty's speed, how long did it take him to catch up to Betty? Okay. Well, a couple of moving parts over here. So going in the east direction, and the acceleration is constant. So he's right now had to stop. So he starts from rest. I'm talking about Aaron. Acceleration is constant. Um, okay, just as the light turned green, so right at this point, Betty passed her, right? And she's traveling at a constant velocity, so that's good news. And it took Aaron t time to accelerate to Betty's speed. So let's say after this time, when Betty was still traveling with the speed v, Aaron is also Aaron is able to catch up. Sorry, Aaron's speed is also same as Betty's, so his speed is also v at this point. And we know that it took t time. So I think just from this information, we can have some relationship between the v and the t. Because I'm going to say that v final, which is also v in this case, so v final is equal to v initial plus at. V final is v for Aaron. He starts from rest. Acceleration we do not know, and time is definitely capital T. So I have the value of a from here actually, it is v over t. So let's keep it aside. Maybe we'll use it sometime. Now the next scenario is how long did it take him to catch up to Betty? Let's say it took t time, and we know that both should cover the same distance, and distance and displacement are same in this case because they are not changing the direction. So in that t time, can we agree that Betty covered vt distance? And in that t time, we need to find out how much distance Aaron covered. So I think I can use the second equation of motion, which is s is equal to v initial times t plus half a t square. I already I don't know the s, of course. So s will be equal to, he starts from rest, so 0, half, a is v over t from here, blue box, and t square small t, what I need to find. And don't you think this s and this s will be same because they are, he catches up, so they cover the same distance. So vt will be equal to half v over capital T times t square. V and v is gone, and if you realize one of the t is also gone, so 1 will be equal to 1 over 2t times small t, and multiplying both sides by 2t, so 2t will be equal to small t, or small t is 2t. So actually in double that time, Aaron will be able to catch up with Betty. Excuse me. I hope this makes sense. It was a little tricky, but yeah, that's how it works. Okay, Romeo and Juliet drove their car horizontally off a cliff at height h, oh my goodness, at a speed of v. They landed a distance d from the base of the cliff, and this is, we are now entering the projectile world, guys. If the cliff had been 4 times as tall and the car had the same initial velocity, how far from the base would they land? So this is h, right? This is they jump off with v, and they land at a distance of d. And they are saying that if the height is now supposedly 4 times and this v is still the same v, then what will be this distance? See, I can definitely do the math for you, but try to understand this analytically. This distance will depend on speed and the time of flight, right? So right now, I'm going to say that distance is equal to v times t, where I don't really know what t is. And when the height is 4 times, then the distance will be, in that case, the distance d dash will be again v times some new time. And that time depends on the vertical height. How? By using the second equation of motion. So if you realize, if I apply the second equation of motion in the vertical world, I know that displacement is h going downwards. I know we take downward direction as negative, but I mean, okay, just to avoid any confusion, I'll do that. So I'm going to use v is equal to, s is equal to v initial times t plus half at square. S is minus h. Initial vertical velocity is 0 because it is thrown horizontally. Acceleration is, of course, gravity, negative g, and time of flight is t square. So negative and negative is gone. Multiplying 2 both the sides and dividing by g both the sides. So 2h over g is t square. So I have the time of flight as square root of 2h over g. Now think about it like this. If you really quadruple the height, don't you think that the time of flight will double? Because this factor, this h, will now be replaced by a factor of 4h. And what is the square root of 4? Isn't that 2? And the time of, and everything else remains the same. Just don't be confused with this 2 over g. If I were to break down the math, it will look something like this. Some constant k times h. Now t dash will be root of k times 4h. The square root of 4 is 2. So 2 root kh, right? And what is root kh? Isn't that the old time? So t dash will be 2 times t. So since the new time is twice of the old time, the new distance will also be twice of the old distance. So that is not anywhere in the option, so I'm going to mark option E as an answer. If you think otherwise, let me know in the comment section, but I think this is how this should be approached. Okay. A car was driving due east at 8 meter per second while a truck drove due north at 6 meter per second. At what speed and in what direction was the car moving with respect to the truck? We are talking about relative velocities now. East is right over here, that is 8, and north is right over here, that is 6. This is V car, this is V truck. We need to find the direction of the car with respect to truck. So direction of the car with respect to truck is given by velocity of the car minus velocity of the truck. Velocity of the car is definitely on the right side, but remember that whenever we take a negative of a vector, because this can be written as plus of minus velocity of the truck, the velocity of the truck will be exactly in the opposite direction. So now we reverse this. This is 6 and this 8 is already here. So this is 8 over here, and basically we are adding the two vectors now because I already took the negative of this vector already. This is negative of Vt, this is Vc, and now I'm going to add these vectors. So obviously it will be somewhere over here. Using Pythagoras, 8 square, 8 and 6 is a pretty popular Pythagorean triplet, so that will come out to be 10. And the direction is definitely south east. Southeast is right over here, which should be option C. Okay. Two sailboats, the Breeze Sneeze and the Wind Fair, were racing by uh, tacking back and forth upwind. Oh, they justify what they explain what tacking is. Tacking means changing direction similar to zigzag. Okay, fair enough. Um, the BS sailed D units east, then D units north, and the WF sailed D plus 1 east and D minus 1 north. Both boats began sailing at the same time and sailed for T seconds. Which boat had the greatest displacement during this time? Okay, so BS is going D units east and D units north, and WF is going D plus 1 units east and then D minus 1 units north. Displacement, they're talking about displacement. So I think, isn't that just about finding or using a Pythagoras theorem to figure this out? So for BS, let's call it x. So x will be equal to square root of d square plus d square, which is equal to root of 2d square, which is equal to root 2d. I don't think so this has anything to do with the time, because had they were asking average velocity or something, then time is important. Otherwise, time is not needed. Let's say this is y, so y will be square root of d plus 1 square plus d minus 1 square, which will look like a plus b whole square is a little bit of SAT coming in. A square plus b square plus 2ab, and this will be a square plus b square minus 2ab, guys. I hope you know these formulas. These are really basic, and if you don't, then please revise your algebra. These two are gone. So I'm left with d square plus 1 and d square plus 1, which is honestly 2 times d square plus 1. And what is root of 2? That's just root of 2. And I'm left with root of d square plus 1. And you know what? I'm going to rewrite this one also in a way that will make it easy for us to compare. That can be written as root 2 times root of d square. Now tell me, guys, which one is a bigger number? Obviously the other one, right? Because this is same, this is same, root is same, but this guy has a plus 1 to it. So plus 1 to it means this is a bigger number. So this is a bigger number means the square root is also bigger. So WF, I think that is our answer, that has the greatest displacement during this time. Hope that's clear. Okay, next one, we have the x and y coordinates of a particle as a function of time are given by x is this and y is this. At t equal to 2, what is the magnitude of the acceleration? It's pretty straightforward, guys. The only difference is now we have acceleration in both the directions. So what is the acceleration in x direction, or let's call it, what is the velocity in the x direction? That will be dx over dt. What is the derivative of this guy? I think that's 5, and this one will be 1.5 times 2t. So that will be 5 plus 3t, right? But I'm interested in acceleration, so acceleration will be dv over dt. The derivative of this is just 3. Okay, meter per second square. What about y direction? So vy will be dy over dt. What is the derivative of negative 60? That's just negative 6. And what is the derivative of negative 6? Isn't that just 0? Because the derivative of a constant is 0. So there is no acceleration in the y direction. The answer is just 3. This time is irrelevant because my acceleration is just coming as a constant. So it doesn't really matter at what time you ask. It's just always going to be 3. Okay, more projectile. An arrow is launched 30 degrees above the horizontal with an initial speed of 20 meter per second from the top of a watchtower. Okay, so from here, this guy is launched something like this. This is 30 degrees and this is 20 meter per second. After 3 seconds, what is the arrow speed? So be careful when they are saying arrow speed, you need to find the sum of the horizontal, the sum of the magnitude of the what do you call? First, you have to find the horizontal and vertical components of the velocity, then take both into consideration to find the speed, right? That's what I wanted to say. Let's make the components of the velocity. We know that Vx will always be a constant and the x component of this will be the cosine component. So 20 cosine 30. Cosine 30 is square root 3 over 2. Obviously, you can, just use calculator, honestly. So I'll do that later. Let's first write as 10 root 3. Okay, this will remain constant. We agree on this, right? Because in projectile, if the air resistance is ignored, then the horizontal speed remains constant because there is no acceleration in that direction. For the vertical world, the initial vertical velocity will be v sine theta. So 20 sine 30. If you find 20 sine 30 is 1 over 2, but you can use a calculator as well. So that's 10 meter per second going up. Uh, and in the vertical world, acceleration is obviously negative 9.8 meter per second square. I know that the time is 3, and they are asking what the v final y is because they are asking the velocity after 3 seconds. So I think I can just use the first equation of motion, which is v final is equal to v initial plus at. So this is going to look like v final is equal to v initial 10 plus acceleration minus 9.8 and time is 3. I can grab my calculator. 9.8 times 3 and 10 minus this guy is negative 19.4, guys. Negative 19.4 meter per second. Okay, the options definitely try to trick you because 19.4 is in the options, right? But like I told you that you have to take both the pieces together and do the Pythagoras. 10 root 3 is approximately 17.32 meter per second, and you need to find the total speed. So now I know that one velocity is towards the x direction, which is 17.32, and one velocity is downward. How do I know it's down? Because that's negative, although it doesn't really matter. 19.4, and this is what I need, which is the hypotenuse. So I'm going to use 19.4 square. This answer will be square root of 19.4 square plus 17.32 square. So 19.4 square plus 17.32 square. Square root of this is around 26, somewhere around 26, which is definitely option C. That's the answer. All right. Consider a ball thrown from level ground with its initial velocity making some unknown positive acute angle with the horizontal such that it follows a parabolic projectile trajectory. In the absence of the air resistance, the ball flies up to some maximum height and then vertically returns to its initial position some time t after being thrown while being horizontally displaced at a constant rate. When the ball reaches its maximum height, which of the following must be true about the ball? Okay, they have given a lot of an entire paragraph, but yeah, it's just that it is thrown like this. It's launched at this point, lands at the same height, and at maximum height, they're asking it had the same horizontal speed it did initially. Don't you think this is the correct answer? Because the horizontal velocity always remains the same, right? They are ignoring air resistance, I'm pretty sure. Have they mentioned? Yeah, in the absence of air resistance, I think this should be correct because this is not really going to change. But let's read the other options. It has same vertical speed it did? No. Vertical speed at this point is 0. It had the net acceleration of 0? No. Acceleration is always g downwards. It is momentarily at rest? No, because it has velocity on the right side. So definitely, this was pretty straightforward, right? The answer is just option A. Okay. At an airport, a student starts to walk backwards on a moving walkway. That's brave. The student accelerates at the rate of negative relative to the platform, and the platform moves with a constant speed of 1 meter per second relative to the floor. In 4 seconds, how much will the student have displaced relative to the floor? I hope you understand the scenario. Uh, this is a platform which has its own velocity. It's moving with 1 meter per second on the airport, and this is floor, which is obviously not moving anywhere. So in usual cases, you just stand on it, it will take you without any effort. But this brave student, what he does is he starts moving backwards with his own acceleration of 0.5 meter per second square. So they are asking with respect to floor, how much will the student move? So I think I can use the second equation of motion, but keep in mind that the initial velocity, although the student himself just starts, so it looks like he starts from rest, of course, but since he is already on a platform that is moving, the initial velocity of the student will be 1 meter per second to the right. Acceleration is negative 0.5, of course, and the time is already given to us as 4 seconds. So I can use the S equation, the second equation, I mean, that S is equal to V initial times T plus half AT square. V initial is 1, time is 4, acceleration is negative 0.5, and time is again 4. This will be 4 plus 1 over 2 minus 1 over 2 and 16. Uh, 1 over 2 and 1 over 2 will become negative 1 over 4 times 16. 16 over 4 is 4. 4 minus 4 is 0. So it looks like he's not effectively displacing anywhere with respect to the floor. So the answer is option D. Right. Over here, they are saying that the projectile is launched upward at an angle from a height of 0. Ignoring air resistance, which of the following pair of graphs best represents the Vx and Vy while the projectile is in the air? I'm assuming air resistance. Oh, yeah, they have clearly mentioned that air resistance is ignored. So the best way to eliminate the options is to see where is Vx constant, because we just learned that in a projectile, the horizontal velocity remains constant if the air resistance is ignored. That happens not in A, not in C. So it has to be either B, D, or E. Now Vy, the way Vy works is initially Vy is maximum positive, then at the topmost point it becomes 0, and then while hitting the ground it becomes maximum negative because it is in the opposite direction. So it definitely changes the direction because we are talking about velocity, not speed. And honestly, there is only option E that indicates that the Vy is actually changing the direction, because these two are saying that the direction doesn't change. How do I know the direction? By the sign of V. So it is going from quadrant 1 to quadrant 4, and that's why I will pick option E as the correct choice. Okay. Right, over here we are given that which of the following types of motion could be represented by these equations? So that's parametric equations. Okay, x is at square and y is bt square. Okay, I'm thinking to take the derivative and finding the acceleration because I'm feeling that if I take the double derivative, then this acceleration will come out to be constant. What do you think? Because I'm saying that Vx will be dx over dt, derivative will be a times 2t, that is Vx, and the acceleration will be dv over dt, and the derivative of velocity will be a times 2 remains as it is and derivative of t is 1, so that's just 2a, that's ax. And likewise Vy, honestly I don't really need to do that because the only difference is a is just b, so ay will be 2b. So acceleration in x is same, acceleration as y is same, which means that the total acceleration in x is constant, acceleration in y is constant. So the total acceleration is constant. So I will say it is a uniformly accelerated motion. So option E makes the best sense to me. What do you think? Okay. Over here, there are three balls that are tossed from the top of a building. Ball A is released from rest, B is thrown horizontally with V naught, and C is with 2V naught. So which of the following correctly lists the ball in order from the time of fall? Don't you think it is same, honestly? Because we just discussed this thing a couple of pages before, that the time of flight only depends on the vertical height, not on the thrown velocity, horizontal thrown velocity, because that will change the distance from the base of the cliff, but not the time of flight, because that just depends on the vertical height and gravity and those stuff, which is same in all the cases. So I'm going to mark option what, D, because it is same for everything. Okay. A hobby rocket reaches a height of this and lands this meter from the launch point with no air resistance. What was the angle of the launch? So that's pretty straightforward, I think, because they are saying that it goes like this, a regular projectile, and this is 111 meters, and this is 72.3 meters over here. And they're asking what was the angle of launch. Alright guys, here I'm going to use some direct formulas that I would recommend you to memorize as well, because these formulas are not given in the formula sheet, but these are super helpful in MCQs. These formulas, the formula that I'm talking about is the range of a projectile, provided the projectile starts from a point and lands at the same, a height, the same height. The range is range as in this horizontal displacement, has a formula V naught square sine 2 theta over g, and the height, the maximum height, which is given to us as 72.3, is V naught square sine square theta over 2g. Okay, they're asking angle of launch. So what I'm going to do is, from these two equations, I'm going to divide them because V naught doesn't really have any job here and I want to get rid of that. So R over H will be equal to V naught square sine 2 theta over G over V naught square sine square theta over 2G. Be careful, we need to use keep change flip. So R over H will be equal to V naught square sine 2 theta over G multiplied by 2g over v naught square sine square theta. G and G is gone, v naught square is gone. Let's sub in the numbers here. So 72.3, sorry, 111 is the range and 72.3 is the height. And this is 2 because this 2 is left here. 2 sine 2 theta over sine square theta. You can use the graphing calculator now, or Desmos, of course. How I will do using Desmos is I will type in 111 over 72.3 minus 2 sine 2 theta over sine square theta expression in Desmos and set it to the degree mode and find its x-intercept. Let me show it to you. So this is how it looks like. I just typed in the entire expression. Obviously, I replaced theta with x because that's the variable that Desmos understands. And I already changed it to the degree mode. So the point of intersection that I'm getting, the x-intercept is 69 around. Fortunately, that is in the option. So it was a pretty good question. So the answer is option A. That's what we have. Okay. Uh, Next question, the spring-loaded gun can fire a projectile to a height of h if it is fired straight up. If the same gun is pointed at 45 degree from the vertical, in terms of edge, what is the maximum height uh, that can be reached by the projectile? Okay, so I'm assuming that the velocity remains same, right? So in this case, it is just going up with v, and it reaches a height of h. Let's find the height of h. I think we can find it because v final is 0. So I can use the third equation of motion, which is v final square is equal to v initial square plus 2as. This is 0. V initial is v. Acceleration is minus g, and s is h. So this will become 0 is equal to v square minus 2gh. So the adding 2gh both the sides, and then dividing by v square. So sorry, divided by 2g. So v square over 2g, that's the height that we are getting initially. Now, if it is fired from a projectile, again, I'm going to use the direct formula that I just used in the previous question. It is at 45 degree. So height will be v square sine square theta over 2g. So v square over 2g remains as it is, and theta you are saying is 45, so sine 45 square. And what is sine 45? 1 over root 2. And what is the square of 1 over root 2? That's 1 over 2. And isn't v square over, let's call it h dash, and isn't v square over 2g something that I can just see over here, which is just h? So this will be h times 1 over 2 or h over 2. So half of the height is our answer, which is option C. Right. Two trains depart from one station, one going north at 30 miles per hour and another going northeast. Okay, fair enough. At what rate does the distance between the two trains increase? This is a fancy way of asking what is their relative velocity. One is going north, there you go, 30, and one is going northeast. So northeast is like this, 45 degree and 60. They are asking what is the relative velocity. Relative velocity means what is the velocity of 1 minus velocity of 2. First, I would like to make the components of this velocity because this is at an angle. So the horizontal component will be 60 cosine of 45 degree and 60 sine of 45 degree, right? So these numbers are around 42.43. So 42.43 upward and 42.43 to the right. Now, whenever we subtract velocity, we take the we change the direction, right, of whichever vector we are subtracting with, and then we are supposed to take the absolute value. So if we change the direction, this will become left 42.43 and down 42.43. So another way to if you do not really like this method of changing the arrows and all, I can tell you another way in which you write this guy as 30 j cap. I hope you understand what is I cap, j cap. J cap is just towards the y-axis. And then you subtract this with the vector, this vector, which is 42.43 I cap and 42.43 j cap. Right, and then you take the absolute value. So this will be minus 42.43 I cap, then 30 j cap minus 42.43 j cap. So what is 30 minus 42.43? That's negative 12 point. So this will be negative over here. 12.43 j cap. Sorry, yeah, j cap. And the absolute value of this will be square root of Pythagoras, right? 42.43 square and then 12.43 square. I'm not writing negative because even if you write the negative, you have to square the negative, which will become positive. So there's no point of writing that. And if I do all this, I'm gonna get 44.2 miles per hour. So that should be our final answer. I hope you guys understand this worksheet pretty good. I think the types of questions were honestly everything from free fall, projectile, kinematics, relative motion, and everything that is covered in Unit 1. I hope it makes sense, including the calculus, of course. If you like this video, please like and subscribe, share it with your friends. It will also help my channel. And if you need private tutoring, feel free to reach out. I'll see you in the next video. Bye-bye.